All right, lesson 2 of unit 6 is going to look very similar to yesterday's lesson, but the difference, as you can see here, is that we're still adding and subtracting, but with unlike denominators. Everything yesterday had same common denominators in our fractions. Today, however, that will not be the case. So just like before, we've got our list of steps to follow. First and foremost, step 1, we're going to factor each denominator completely. If possible, sometimes that'll already be done for us, or it's something that can't be factored. The reason for that is step 2, our goal is to find the LCD here. In order to do that, we're going to start by highlighting any common factors between all of the denominators. And then to find the LCD, we're going to take the highlighted factors times anything in addition that is not highlighted. So we'll put all of those together. And this will go back to something that we did way back at the beginning of the course when we were solving equations with fractions. Step 3, we're going to take the numerator and denominator of each fraction and multiply by the missing factors from the LCD. And we'll see that as we do our examples. Step 4 is going to be the same as the step yesterday, where we just add the numerators because we now have a common denominator. And then again, it's important that we're simplifying our final answer as much as possible. So look for that at the end. So let's go ahead and take a look at example 1 here. So first and foremost, I'm just going to factor each one of the denominators right underneath it. So if we look at x squared minus 5x, we can take out the x. And if we look at 5x minus 25, that also has a GCF. In this case, it's 5. Now grab a highlighter and notice here that they both have a factor x minus 5. So when we're writing our LCD here off to the side, not in highlighter though, the LCD is the highlighted factors times anything in addition to that. So note that over here we have an x and a 5 that didn't get highlighted, so those also have to be part of the least common denominator. So our LCD here is going to be 5x, the two things that were not highlighted, times x minus 5. And while we're at it, just to review, if this is our least common denominator, let's talk excluded values for a minute, or domain restrictions. If 5x and x minus 5 are the two factors, I can set each of those equal to 0, and that'll tell me numbers that are not possible to plug in as x. So if 5x equals 0, that means 0 would be a problem. And if x minus 5 equaled 0, that would be when 5 is the x value there. So 0 and 5 are numbers we would not be able to plug into this overall expression. All right, so let's take a look back up here for a second at our steps. So far, we factored each denominator, we highlighted and found the LCD. Now step 3, we're multiplying the numerator and denominator by the missing factors from that LCD. All right, so let's come back down here. We want to multiply each original fraction. So we're going to multiply this one and then this one by the missing factors in the denominator to complete the LCD. So if I look at the first one, I have x times x minus 5. So what part of the LCD is missing? Well, hopefully you said 5. If we look at our other denominator, 5 times x minus 5, again, what part of the LCD is missing? Well, we need to multiply by x to complete it out. So now the LCD is going to be the common denominator. So we can put the 5x times x minus 5 on the bottom. And now I can do the addition across the top. However, note that this is a subtraction problem. So before I go any further, I'm actually going to change this to addition and add the opposite. So that way I can just add the numerators together. So first fraction is 5 times 5. That'll give me a 25 on the top. And then we have negative x times x, which will get me negative x squared. Last step, now that we've combined into one fraction, is to simplify, which means we have to try and factor and reduce common factors. So the top should look like a dots problem to you. We can make that 5 plus x, 5 minus x, still all over 5x times x minus 5. And if we look at this, It looks similar, but not identical. I'm looking at the two factors, 5 minus x and x minus 5. They're super close, but not quite what we need. If I take out a negative 1 here, I can change this to negative 5 and positive x. So now those two factors will actually cancel out. So I can cross those two. And my final answer here would be negative 1 times 5 plus x all over 5x. Nothing more in common there. All right, let's take a look at example 2. So example 2, again, first thing we want to do is factor the denominators if that's not already done. So if I look at the first one, 3x squared minus 6x, what technique would you use to factor here? You can use GCF, and 3x should be what we can take out there. So 3x, if we take that out, we'll be left with x minus 2. And then for our other denominator, we have 3 terms. No GCF here, but that means we have to work with trinomials. So on the top, we'll have a 4. The bottom will be a negative 4. Two numbers that multiply to 4 but add to negative 4, negative 2 and 2. And now we can rewrite the trinomial using these two numbers we just found. So x squared minus 2x again, plus 4. And then we use that grouping technique. So we'll take out the GCF of the first two terms, which is just x, and the GCF of the second two terms, which for sure is a 2, but so that I get this x minus 2, when I take out this GCF, I want to take out a negative, because that'll give me positive x and negative 2 left over. So these two now match. So this denominator would be x minus 2 from the parts that I underlined, and then the GCFs make up the other one, which is another x minus 2. All right, so now we have our common denominator, or our factor denominators rather. Again, we need to find the LCD next. So grab our highlighters. What do they have in common? Well, I see an x minus 2 here. I see 2 x minus 2's over here, but I can only highlight 1 since the first fraction only had the 1. So the LCD for sure is going to have an x minus 2 in it, and then it's going to be multiplied by everything else that's not highlighted. So there's a 3x here, so 3x would be part of the LCD, and then there's that second x minus 2. So up to you how you write this. You can write another x minus 2 on the end of our LCD. I'm going to actually square this one to kind of shorten it a little bit. And then that is going to be our common denominator for moving forward. So I'm going to write that in the denominator of the fraction that we're going to build here in a second. And again, you can write x minus 2 times x minus 2 if you don't want to write the squared sign. One more time, I'm going to talk about excluded values here. If 3x is a factor for the denominator, when I set that equal to 0, 0 would be a problem. And if x minus 2 is a factor, 2 would produce a 0 in the denominator, which is another problem for us. So just reviewing those domain restrictions from last week. All right, now, next we need to multiply by the missing pieces from the LCD for each fraction. So if I look at the first denominator, what is missing from the LCD that we found? Well, it's going to be that x minus 2, because there's only 1 in this fraction. For the second denominator, we have x minus 2 times another x minus 2. So we got the x minus 2 squared, but we don't have the 3x. All right, so now we're going to rewrite our fraction by multiplying those two things together. And this one is addition in between, so I can just add straight across the top. So we'll distribute the 7 into that binomial. So we'll get 7x minus 14. And then we've got x squared times 3x, which would give me 3x cubed. Last step is to simplify. So we want to look for anything that they have in common, top and bottom, that we can cancel out. The issue with this one is that the bottom's already factored, so that's good to go. But the top does not have a GCF, and it's a trinomial, so you might be thinking the x games, right? But the problem is that this cube sign right here doesn't allow us to factor using trinomials. That can only be done if there's a squared sign there. So we're actually not going to use any factoring technique because this one is actually done. I'm going to reorder this and put the 3x cubed first, so it's in that standard form where we like the highest power to come first. You don't have to do that. You could have circled the answer in the last step. And again, you can write this as squared, or you can write x minus 2 times x minus 2 on the bottom instead.